problems, and we wanted to have a consistent soft shadow system. And that is possible nowadays through shadow maps. And shadow maps are elegant solution to solve the problem, and on nowadays hardware that's quite good. So there's also some complexity on that, but it's not that needed to go into that much detail right now. Just to show you briefly that this is a small image that shows it's basically an area that in our scene at night, and I placed some light sources. So this is programmer art where I placed those light sources. It's not that good, but there's another image that I show here that is actually the kind of internal image. That is one texture that has in red, green, blue, and alpha stored where is a shadow and where is no shadow, or where is some percentage of a shadow. And that is actually what's internally available in the engine at some point, and it becomes, when we render the whole thing, then it's basically, for each pixel here, we know which part is actually in shadow and which part is not. So we can make in real time, make them the shadows. It's just an intermediate step, basically. It's sometimes interesting to see that. So we can, for up to 4 light sources, easily, we can combine them into such a texture. And that is also, it has offers some benefits. So then when we do usual scene rendering, that's for the shader programmers, it might be interesting to know at some point. What we basically do is we first generate all the fancy stuff like shadow maps and reflections and some little monitors that are somewhere, and all that is done in the beginning. Then a little bit later, basically, I mean, after we finish all those steps, then we create the distance. This is now early Z-pass, it's called usually. And what it does, it's basically we store for each pixel on the screen, we store the distance to the camera. And this is something that usually happens internally in the graphic card. It's used for, it's the Z-buffer algorithm. It's usually used to render everything that you cannot see through objects, and the whole normal Z-buffer relies on that. But what we do here is we basically render that as a first step and don't render any color information so far, so we just have only the Z value. And with that, we can make interesting shading afterwards. So all the volumetric fog, the interesting non-homogeneous fog, alpha with soft clipped particles, and the shadow algorithm, they all rely on that fact that we have the distance already. Because this distance gives you where that point in the 3D world is. That's just good to have. In Far Cry we haven't had that, and our volumetric fog things just looked a bit more poor because it was not possible to make that in high quality. But finally, with that distance, you can in high quality compute where that point is in space, and then you can make the perfect shading for that. So it improves the quality on a lot of things. And also for our current generation graphics hardware, it's cool to have because it's really it's serves this purpose of per pixel. You want to compute something per pixel, then you get it accurate for that point, and not just for per object or per vertex or something. You get really the quality out of it. So then we have a feature. I'm just browsing here through some kind of random features that might be interesting. Dynamic time of day. It's just this feature. Maybe they showed you already that you can change the time, and then the sun is changed. Sun position is changing. The mood of the light is changing. There might be, shadows are moving and all that. It's quite nice to have. But it's something that you also need to know where you want to use it. If you just use it randomly, you probably at some point you cannot see anything because it's too dark and your gameplay doesn't work out. You forget to put light sources there. So at some point you might be just blinded by the sun. So the designer still needs to take care of that. Completely random everything, dynamic time of day, is gameplay-wise not always the best solution, but that's on the gameplay side for the decisions they want to do. Just this screenshot you might have seen already. It's kind of older one that was it's demonstrating basically how a certain scene can look in daylight, and this is probably the same scene those guys were going to bed at night, and someone switched on the light source, so it just gets a different mood. You don't have to model that twice. You just need to set up the materials, change the time of day, remove some guys, switch on the light source, and you get this. As an example feature, I very briefly talk about the ocean. The ocean is, it looks quite, let's show it first. That's one image that I made. at some point. It looks, here you can see, for example, that there is a reflection of this reflection there is a refraction, and the refraction we treated red, green, blue independently, so you get some interesting color effects when you see reflecting stuff throughout the water surface. And there is also these nice little waves and some other fancy effects, but it's so many things that come together that form this basically. And what it is this, which is more take detail that I want to go through right now. So then basically, because the whole thing is, as I said, from beginning on, we wanted to have it for our next generation, should serve the purpose of doing those. What is next generation? It's kind of improving the engine constantly to get more things like breakable or whatever things. But on the hardware side, for the engine, it's the challenge of supporting multiple GPUs or multiple CPUs. And while we worked on that, and the engine serves that, it runs on multiple CPUs, for example, faster, but it's not that it urgently requires it. And it's not that we put all of our effort so that it runs very fast on two cores or 4 cores. It's still 1 core is the main, and then you get benefit. But don't expect that you have a bad performance because of very bad performance because of 1 core. It's just an extra, because it's hard to utilize everything with multiple cores. Win64 is quite useful for us in production, because during production you always need more memory, because you have to load additionally to the game. You probably have some unoptimized assets, and you have to additionally load more data structures for editing. And probably people are using at the same time their Photoshop, their 3D Studio Max, and other things are open. All that costs you a lot of memory, and it just runs nicer if you have 64 bits. You don't run into problems. And so we had that after Far Cry, we had this 64-bit support, and we just maintained it, and for production it turned out to be a good thing to have 64-bit available. And many of our designers are using 64-bit. And we have the DirectX 10 and 9 rendering, and there is some more eye candy on that one possible. Then for big productions, it's needed to have statistics and tests and other things, and that all is also supported. It looks boring from outside probably, but it's something that is very useful if you have a ladder that runs slow. You have to investigate what was happening, when it was happening, and what things you can do now. Where is the problem? If you have thousands interacting things, then this is an issue. So that's it.